Okay, so this is a recording on range versus resolution. I know we talked about this in class, but here's a code, and I want to walk you through it and single step and show you what happens with timer 1, and how you can talk about resolution. For now, let's just forget about range. Let's just focus on resolution. And before I show you the code, let me just go over some of the basics of what this program is supposed to do and how I'm setting things up. So what the problem statement is, I have an external signal, and that external signal is going to be on for a while, and then could be on at different lengths of time and so on, right? So this is the duty cycle. This duty cycle is the one that I want to measure. I want to know how long it is. So the way that I do set up the program is to connect this to the int0 pin on the PIC microcontroller. And you know that with int0, if the signal changes, then your int0if would get set. So you can say either respond to a positive edge or respond to a negative edge. So the way that we set it up is we turn on timer 1, right? And set a really high value for PR1 so that it doesn't overflow that soon, right? And for now, let's give it a prescaler of 1. So let's say that you set PR1 to, let's say, 60,000, and the prescaler is 1. So your value is counting, 3,298. I know you can't read this, but that's not the point. 320.99, and then the edge happens, right? So what you want to do is you want to set TMR1 to 0, and then it's going to count 1, 2, 3, 4, 5, and then at the same time, so when you look at this positive edge, you set up int0, you change its configuration so that now it responds to this, right? So you have a while loop that is waiting for int0if to happen right at this edge, and in parallel your hardware, the timer 1 hardware, is counting 0, 1, 2, 3, 4, 5, and when this happens you break out of the while loop and you note 5 to be the duty cycle. Okay, and then you let it run. So this could go 6, 7, 8. I should show it here. 6, 7, 8, 9. And by the way, when you did respond to this negative edge, again you set it up to respond to the positive edge. And when you look at the positive edge, you reset TMR1 to 0, and then it counts again 1, 2. And at the same time, when you responded to this, you change the polarity. So now that this if, the while waiting for int0 if loop exits, then you note that, yeah, the period was 2, and let it run 3, 4, 5, 6, 7, 8, and again the positive edge happens. You make it 0, 1, 2, 3, 4, 5, 6, 7, and let's say this happened, so you note that my half period was or my duty cycle was 7. Okay, that's what we do. So in order to set things up like this, note that I don't care about TMR1 TMR1's IF, right? So TMR1 at least during this period, right? This could be as long as you want. Maybe it reaches 60,000 and rolls back to 0, 1, 2. And as a result of that, T1IF would get set to 1. But we don't care. We never check for T1IF. We don't reset it. We let it be 1. We don't care about that. So in the program, basically what we have is we are going to have a while int 0if is still 0, do nothing. And in this case, I have set my int 0 edge polarity. I don't remember if this is the exact name of it or not. We'll look at the program. So we'll set it to 1 or 0, whichever that corresponds to the rising edge, right? And here I can just say int 0 if equals 0, right? So this while loop is waiting for this time to finish, right? And here is the time that I can set my TMR1 to 0 to set it up for this part of the computation, right? And also I can say int 0 edge is now set up for the falling edge, and after that I'll have another while loop while int 0 if is still 0, do nothing. So this new loop is waiting for this period of it. And at the same time, in parallel with this while loop, my TMR1 is counting. So the TMR1 value is incrementing to, 0, 1, 2, 3, 4, 5, and so on. And when I break out of this loop, well, I set int 0 if to 0 to be ready for the next big iteration. And here I would say that, half cycle or duty cycle is equal to TMR1, and I don't reset it. Not resetting it means you allow it to go on and on and on, and then you have a loop that goes back up here and repeats the whole thing, right? So every duty cycle you want to know what is the what is the count on TMR1. So I guess the important point here is that if you set TMR1 with a prescaler of 1, then every instruction cycle TMR1 is going to count. So at the end of the day, when it says my duty cycle is 4, it's going to be 4 times the TCY, which is 4 times 1 over 16 megahertz is the duration, right? And again, here it says 2 cycles. Here it says 7 cycles. And that's what we want to test. Now, the other thing that we are going to test later in this video is to change the prescaler from 1 to 8 and see what happens. So I'll come back to this, but just wanted to give you a heads up. So let's go to the code. And in the code, the setup code is first turn off timer 1, set PR1 to a high value so that you don't overflow. And the reason that you don't want to overflow is because of this, right? I mean, I'm assuming that this duty cycle is not longer than 60,000 instruction cycles. If it is, then basically means that it goes from 0, 1, 2 to 60,000, rolls back to 0, 1, 2, 3, and I report 3 to be the duty cycle, right? Which is wrong. So I'm assuming that my signals are not that long, at least for the active duty cycle. If they are long for this period, I don't care. It could the number could be wrong because I don't even look at this number. As soon as I see this edge, I'm going to reset this number to 0. So if you want to overflow in this period, I don't care. That doesn't interfere with the way that the program runs. And this is the part that we are going to uncomment later. T1 con bits in TCKPS. Let me show you the manual. So in the manual, this is the T1 con, and these are the select bits for the prescaler. And the prescaler, if I leave it, because if you remember, I set T1 con to 0, right? I set T1 con equals 0, which means all of these bits are 0, including these prescaler bits, which means I'm choosing a prescaler of 1. Later, we are going to choose this, 0, 1 for TCKPS. That gives you a prescaler of 8, right? So this is is 8. And we'll test with that later. For now, prescaler is set to 1. And I reset timer 1 to 0. I didn't have to because as soon as I see that rising edge, I'm going to reset it anyway. But there is no harm in resetting it here too. And I turn it on. So timer 1 is going to start counting and it's going to wait. And again, this one doesn't matter either, right? So let me say doesn't matter in the code that I'm going to post. And I would say doesn't uh, matter. So it doesn't matter here because we will reset on positive edge on int 0, right? In this case, it doesn't matter the timer 1 if we never look at it, and we don't have any while loops that wait for it. All right, now the main, you set it up, and then basically what I do is I reset int 0 if. I set the edge polarity to wait for the rising edge. And then I wait for that if for the rising edge to happen. And so this part corresponds to this part of the program, right? I'm waiting for the rising edge to show. And when the rising edge shows, I'm going to set my int 0 if to 0, timer 1 reset to 0. Now is the actual counting. So with every instruction cycle, so with this instruction cycle, timer 1 counts to 1. With the first instruction in this while loop, it's going to count to 2, 3, 4, 5, and then the while loop goes back. You keep counting 6, 7, 8. Your timer 1 is still counting, and it keeps counting until you see that negative edge. So this is where you change the polarity, and now when you come out of this while loop, you have the negative edge, and your duty cycle is going to be the TMR1 value. You go back to the loop waiting for the next duty cycle. Okay. Now let's execute it, and if I run it, it's going to go on and on and on, waiting for this, in this while loop, waiting for the stimulus. And I think if I do the stimulus here, oh, it did work, but sometimes it doesn't work. Sometimes if you want to give it a stimulus, just press this pause button, and the pause button is going to allow you to, use this as stimulus. And note the value of TMR1. TMR1 has a value of 11983. So it's been going on for a long time. And what we do is we reset the int 0 if, we reset timer 1. So from this point, we are just counting. We're going to count the number of instruction cycles that happen while your signal is still high. Your int 0 is still high. And this goes on and on. Let me show you. So when I execute just one instruction, timer 1 became 1. Now if I press go, it's going to go for a while, because this while loop with the semicolon is going to take many cycles. So let's take a look at the disassembly. So in the debugging, I'll say disassembly, and here I say go one instruction of the while loop, and see timer 1 became 2. Another instruction of the while loop. So this whole thing from here to here is the translation for this while int 0 if is still 0, right? So the AND instruction is going to take one more cycle. My timer 1 is 4. My branch, so it became 5. My branch instruction, remember, if the branch is taken, is going to take 2 instruction cycles. So when I say that, then my TMR1, which runs in parallel to my CPU, incremented to 7, and then I have 8 and 9, and you see every instruction, timer 1 is counting, up 1 value, incrementing by 1, and this loop will go on and on and on until I set low my int 0. But the thing is, if I set it low, let me fetch. So see what this code is doing. It's moving IFS 0 into W4, and then it's ANDing it with 1 to mask every other bit other than the int 0 if, and then it's subtracting 0 from it to see if the result is 0 or not. And then branch 0 goes back up. Remind me to talk about this W15 at some point. So this is a temporary location on the top of a stack that they're using, but note that there are no pluses. So it's not pushing, it's just stealing the empty location on the top of a stack, and it's using it to store temporary values. But we will get to stack in a couple of lectures, so I do want to talk about a stack in more detail. For now, let's just remember that this is just trust me that this is a temporary location that people use, because they're not interested in the result of this subtraction. And I guess the compiler could have been smarter and just used the CP, the compare instruction. But on the other hand, maybe CP doesn't allow you to compare to a literal. I don't know. I haven't looked at it in detail. So this goes on and on. Now, note that here I moved IFS0 into W4. So if after this instruction anything happens, so if I give the stimulus, now int0 has happened. Ideally, I would like to just set my duty cycle equal to TMR1, which is this 38, but the software is not going to see that because it has already copied the previous value of IFS0, which doesn't have that int0 IF equal to 1. So it's going to go on not detecting that the edge happened, so I counted extra. So from 38 I came up to 40. Now I'm going to go to 42 because of the loop. Now I copy the IFS0, which does contain the int0 IF, right? The int0 IF is 1. You can see that 1 which is red here, right? So now it copies the right value, but it doesn't detect it until it does the computation. So it does the AND, it does the subtract, and now that it wants to branch out, you have counted to 46, right? And so there is some inaccuracy, and I'll talk about this inaccuracy in a separate video, comparing different methods of doing, polling or interrupts, and see, how much overhead you have in detecting things like this. But I mean, take it as is, right? I mean, this is if you don't want to use those input capture hardware that guarantees that as soon as it sees the edge, it's going to capture the value of TMR1 by the hardware, regardless of what the software is doing, then if you don't want to use input capture, then the price that you have to pay basically manually in software looking for that edge on the int0 pin is going to be that you're going to be inaccurate. Instead of 38, you're going to report 46. Having said that, if your signal duty cycle is pretty large, like 3,000 instruction cycles, then if you use 8 cycles here or 10 cycles, who cares? That's not too bad. All right. So the point here is when I move my W4 into W14, which has this duty cycle, then it basically copies the value. So duty cycle is now set to 2F, which I'm sure it's a decimal for maybe 48. Well, I can't do it with this resolution. But anyway, I mean, just trust me that the value of TMR1 that you read after this int0 IF thing is going to be placed in duty cycle. And, you're ready now for the next round of instructions. Okay, so I hope the way that the program runs is clear. Now what we want to do is we want to change the prescaler to 8. Okay, so if assuming that you can ignore the overhead of this while loop to catch up with int0 IF, and assuming that for now, just forget about that. Let's say that doesn't exist. Let's pretend that doesn't exist. Let me go back to my notes here. So here, if I have a signal that does this, and let's say my timer 1 is counting 0, 1, 2, 3, 4, 5, right? Then if you tell me that timer 1 has a value of 5, I know that this signal happened at 5 times 1 over 16 megahertz, which is 0.0625 microseconds, right? So you know that this is how long the signal took to come down here. But you can't have any resolutions finer than that 0.0625, right? If your signal goes down here, you would still get 5, right? If your signal goes down here, you would still get 5. So when you get a value of 5, then essentially it means that your signal could have happened any time between. So your signal edge, the duty cycle, is definitely greater than 4 times TCY, right? And this is TCY. And it's less than or equal to 5 times your TCY, right? So the resolution at which you can determine when this edge happened, could have happened here, the resolution is 1 TCY, which is 0.0625 microseconds. Now, if you look at a signal like this, okay, and let's say this is your TCY. Okay, now if I set my prescaler to 1, I'm going to count. So let's say this happened, right? So you're going to consider this to be the period of the signal when your prescaler is set to 1. But if I set my prescaler to 8, okay, then what happens is that I have, so these are the instruction cycles, the actual CPU running add, subtract, and so on. So this would be instruction 1, which is add, instruction 2, which is subtract, for example. This could be AND, this could be branch, 0, these two, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so if you run the program with prescaler equal to 1, it will tell you that the duty cycle is 22 times 0.625. Now, if I set my TMR1 to have a prescaler of 8, what does that mean? And I set it to 0 here. Then your prescaler 8 means that every 8 instruction cycles, my TMR is going to count to 1. So you have 1, 2, 3, up to 8, and it counts to 1. And then it keeps at 1, it counts to 2. Then it keeps going, right? And it would have turned to 3 if your signal had kept going, but you never reached that, right? I mean, so you get up to 2, and that's what you get, right? Now, what does a value of TMR1 equal to 2 mean? It basically means that the edge, the falling edge of the signal could have happened anywhere after the 16 all the way up to 23. If the signal happens anytime in between these, then I'm going to break out of the loop and read the value of 2. And remember, the loop breaking out of the loop depends on int0if. It doesn't depend on timer 1. So it doesn't care what prescaler timer 1 is using, right? So if I break out of the loop and I read the value of the timer equal to 2, the edge could have happened here, it could have happened here, it could have happened here. I don't know. I don't know where exactly it had happened, right? It could have happened right here, right? So all I can say is that my signal happened at 2, and remember this 4 value came from here, this 5 value came from here, right? So this 2 value times 8 times TCY, and sorry, I was wrong. So yeah, here if you read the value to be 4, that's what happens. So let's say that the edge happened right before this 5 happens. So your duty cycle, your TMR1 would give you a value of 4, right? So this has to be less than or equal to, and that has to be strictly, DC greater than or equal to 4, strictly less than 5. So here exactly the same thing happens. So it's either equal to exactly 16 cycles, or it could be 20 cycles, 21 cycles. At any rate, it would be strictly less than 5 times 8 times TCY. Okay, sorry, not 5, 3. The value here would have been 3. Okay, so now, so when I ask you what is the finest resolution at which you can tell me when the signal went high or low, then essentially you would say 8 instruction cycles is the finest accuracy, the finest resolution that I can tell you when the signal changed polarity. And let's take a look at the code and do the simulation here. So I uncommented this line that now uses a prescaler of 8. And now let's go ahead and compile and run the code. And again here, it helps if I look at the assembly, because assembly then shows you instruction by instruction what's happening. So the code is now running. It's stuck in that while loop that is waiting for the first edge. So it's stuck in here, and I give it the first edge. Let's see if it works. Yes, it does. So look at the value of TMR1. It has 7,000 something something, and we're going to reset it to 0. Now let me show you that disassembly listing, because then that shows me instruction by instruction what's happening. So in the disassembly listing, I reset my int0. I changed the int0 EP to now wait for the falling edge. Now note that my TMR1 is not changing. Let me execute instructions one by one. So this instruction goes 1, 2, 3. Now timer 1 became 1, right? So every 8 instructions it's going to count. Now let's count instructions. 1, 2, branch is going to be 2 instructions. So 3, 4, 5, 6, 7, 8, 9, and this has to go to 2. See? So I counted 9 instruction cycles that my CPU is running. TMR1 in parallel, independent of the CPU, is looking at the TCY, and it's saying I have a prescaler of 8, so it's now counted to 2. So when it counts to 2, that means that so far you've had 2 times 8 instruction cycles plus some more, right? I mean, plus up to 1, up, plus 3, up to plus 7 instructions. So this 2 basically doesn't tell you exactly how many instruction cycles you've had. You can just say in multiplies of 8 how many instructions you've had, right? So when timer 1 tells you I'm 2, that means you've executed anywhere from 16 instructions up to 23 instructions, and it's still 2. So you don't have as much accuracy in saying how things work. And again, you do have that overhead. So if I reset my my signal, the falling edge might not be seen until the next loop iteration. But I mean, that's the part of the overhead that you have with polling anyway. And here you report the duty cycle to be the value of TMR1, which is 4, and that's the value that you would keep here. Okay, so this is the discussion about resolution. If you get resolution, then the talk about range isn't that difficult, right? So if you think about the range, I said that during the active duty cycle, my timer 1 is counting, right? So my timer 1 is counting, and let's say for now it's duty cycle, it's prescaler 1, right? So it counts up to 1, 2, 3, 4, 5, and so on. It may reach to 59,999, and I would be still okay if the edge happens here, right? I would report a number from 0 all the way up to 5999, but if that 599 and 60K happens here, and I reset back, the timer 1 will automatically reset 1, 2, and let's say up to 100, and then the edge happens, I say duty cycle equals 100, then this number would be wrong, right? So the range would be up to this count that I have. Now in this particular code, I set PR1 equal to 60,000, right? That would limit my range to be 60,000 TCY. If my active duty cycle is any more than 60,000, I'm not going to give you the right answer with the code that I've written. The code that I've written doesn't care about the overflows, right? And usually when we talk about range with respect to timers, we mean without an overflow, what is the range? Okay, so that's how many instruction cycles I can catch. The theoretical maximum is when I set this to 65536 times TCY. That would be the range when I set my prescaler to be 1. Right? Now, when I set my prescaler to be 8, remember, instead of the instruction cycles, every 8 of them that happens, I'm going to count to 1. And then another 8 goes, and I count 2, and so on. So I'm fine up to the point that I'm counting 59,999, right? With the 0 that you have here, I have 60,000 times 8 instruction cycles is my safe range. If my duty cycle is less than this value, I'm okay. Whatever value that I report to you, it's okay. So you can see that range and resolution would give you, trade-offs. If you want the highest resolution, your range would be smaller. If you want 8 times the range, then you have to be happy with, 8 times worse the resolution. Hopefully this clears up any ambiguities that you have, any doubts with respect to range versus resolution, but feel free to ask me. I'd be more than happy to answer. All right, thank you.